Well, it's just after New Year's and I'm in my parents' kitchen in Detroit, Michigan, and we're watching the house for them, and they asked me to take a look at their oven. So I'm gonna show you what I found, but maybe more valuable than that to the certain viewer, I'm gonna show you how I found it, how I thought about it, how I tested it, and maybe you'll find yourself along the same lines with a different finding, but sort of my approach or diagnostic steps might be helpful for you. I'm also going to make a few comments about how to become more comfortable working on AC voltage in a house, especially if you're familiar with working on like 12 volt DC, like from a car. The differences are not as vast as you might think, at least from a diagnostic standpoint. And so hopefully this will be of some value to you. Okay, in case this is helpful to someone, this is a Kenmore 790-723-03011. This is a gas oven, and basically my dad said that they turn it on to bake, and after 20 minutes, it's still not warm at all. So the first thing that I did was get familiar with it. I have an electric oven at my house, so I just pulled it away, took a quick look at the wiring, saw what I was working with. I already had a pretty good idea. I've worked on some stuff like this before, although not significantly, but I've worked on a furnace, I've worked on an air conditioner, I worked on cars, so you kind of start to get a sense of what elements are going to be in there. So anyway, first thing I did is I hit the bake button and I wanted to see what it would do. And the first thing that I noticed was at the bottom here, I already taken some of these pieces out, but at the bottom over here, with nothing removed, just like a normal customer would be using their oven, I could see like a glowing red light. And so I was like, okay, well, that's interesting. And I figured that was some sort of igniter, glow plug, something like that. But the gas never came on and I could never really smell anything. Now the stove works, so I know that the oven is getting natural gas, and I know that there's no like mainline restriction or anything like that. So second thing that I did is I turned on broil. I turned off bake and turned on broil and let it sit for a couple minutes. And I saw that same red glowing up here. There were a lot of pieces here at the time, but nonetheless, it was glowing. And then the flame came, basically the natural gas got turned on and I could see the flames and the broil function was working. So that kind of told me at least, the natural gas system in general is working, which I kind of already knew from up here, and also confirmed what those glow plugs were. That's what I thought they were, but I didn't know if they were going to be like electric, piezoelectric, or whatever. So this is what I was seeing. So basically, you have two of these, one for bake, one for broil, and these things get scalding hot and are glowing. Okay, so in the end, this is what I found, which was wrong. So if that's helpful to you, stick around. If you know it's not those, then maybe skip out. But I'll just tell you kind of how I approached it, how I looked at it. So unfortunately, the wiring diagram was already missing from this. I think someone worked on it before and didn't return it. So I just kind of got back here and started poking around to see what I had, how things were configured, even though I didn't have a wiring diagram. And I came down here to the gas valves. Ironically, what I should have done, but didn't, is I should have taken measurements from over here because it's much easier to get to the gas valves, but I hadn't quite figured that out yet. So anyway, so I checked to see what kind of voltage I was getting to this gas valve here, and it was only 3 volts, which was pretty surprising to me. I also figured out that first gas control valve was the one that went to the broiler, because this is where the gas comes into the broiler. And then I could see there was another one which went to the bake, but I couldn't get to it because I hadn't realized you could get to it from the front. So what was interesting is I took a voltage measurement when the system was off. Then I had my wife turn on the bake function, and it slowly crept up to 3 volts. It didn't just flip on to 3 volts, which is not a super common characteristic, at least when you're working on a car. So I thought that was kind of odd. And 3 volts is not a lot of volts. It's not something you see very often on cars. You see it in electronics like Arduino, but 3 volts is pretty low. And so I thought that was a big part of the problem. I thought, okay, the gas valves aren't getting what they're supposed to get. Then I went to the other gas valve, which is over here, and it wasn't even getting half of a volt. So the bake control valve was only getting half a volt. The broiler control valve was getting 3 volts, and the broiler was working. So all of a sudden it seemed like, well, maybe there's nothing wrong with 3 volts and there's something wrong with half a volt. So I took a look at the wiring, and you could just, using a flashlight and looking at the colors, recognize that the way this works is the control board sends voltage to these igniters or glow plugs or heater elements or whatever you want to call them, and then it's a series circuit. The voltage comes in and then goes down to the gas control valves and to ground or neutral or whatever terminology you're familiar with. So there's not a lot of series circuits in cars. Most of them are parallel. So I started thinking about that a little bit. And I took a ohms measurement of the heater element and of the control valves. The control valves were only at like 1.5 and 2 ohms, which is not a lot. And then the heater element up here, which was working, was around 250 ohms. So I poked around on the internet. I asked ChatGPT what were some common resistance values since I didn't have a wiring diagram, and kind of felt like I was onto something. Then my brain started working, and I realized that if I remove the drawer, the heater drawer, then I could look in here, and lo and behold, on the gas valve, it says, do not apply 120 volts. And then down at the bottom left, it says 3.03, 3.3 VAC. So basically this control valve is saying that it's gonna take 3 volts alternating current. So that was a nice confirmation that the 3 volts I was seeing on the broiler valve to the left was correct, and that I shouldn't expect to see anything like 120 volts. I also did what's called a voltage drop, where you basically take, well, not basically, to do a voltage drop, you take the black lead of a multimeter and you put it to ground, or in this case, what residential electricians call neutral, the white wire typically. Then you take the red wire and you go to the incoming voltage to the heater element, which was 115 volts, and then you go to the outcoming connection, which was 112, which basically meant the voltage dropped 112 volts as it went through this resistor. And that left 3 volts for the control valve. Now, at first, I thought that was suspect until I saw the comment. And you have to understand that the resistance values of the solenoid and the resistance values of the resistor can act on one another. So if one goes down, then this one will start to drop more voltage. Now, if you're not familiar with amperage, voltage, and resistance, one helpful analogy would be to think of a garden hose that you turn on, and let's say 120 pounds of pressure comes out of the garden hose, but then you're stepping on the garden hose and kinking it, and then your brother is also stepping on the garden hose and kinking it. And so the pressure drops from 120 to, let's say, 20, because you're stepping on it and kinking it, and then there's 20 psi going through the hose, and then it drops to 0 after your brother is kinking it, and then it just dribbles out the end. That's a useful, although not complete, analogy for thinking of voltage, amperage, and resistance. Now, if you are unfamiliar with alternating voltage, which is what you'll see here in a house, and you'll use that on a multimeter, and you're only familiar with direct voltage, there are some important differences. There are also some scary differences, because it takes about 30 volts for your body to become a conductor. So below 30 volts, you can touch whatever you want. You won't get electrocuted if you're touching with dry skin and you're not rings and things like that. But in a house in the United States, there's 120 volts. In Europe, it's 240 volts. And you will get zapped or shocked if you touch the wrong thing. So a lot of people are intimidated. However, if you're familiar with a multimeter and if you're familiar with some diagnostics, it doesn't have to intimidate you to the point of failure or not even trying. Just flip your meter to VAC, and you can use these and you can touch whatever you want, wherever you want. You'll have no problems at all. The only thing you have to avoid is that as you're probing in a location, you can't touch two things and then let these touch each other. So if you were to, let's say, crisscross these and then probe, then you would have a direct short. And that would be no different than taking a fork and putting it into an electrical outlet. However, if you keep it on VAC and you probe around and you make sure these don't touch, you can touch anything you want. You'll never have a problem. Now, that is not true if you flip this to resistance. I won't get into the details as to why that is, but when you use resistance, you're not just measuring voltage, you're actually sending out voltage. and then measuring what returns. It's a totally different setup internal to the meter, and you cannot just probe around wherever you like. Okay, last thing I want to say about VAC and DC. If you go to a DC circuit like a car, we say that ground is 0 volts and positive is 12.6. In a house, it's not quite as simple in theory because the current is moving back and forth. So it's not as linear as it comes out 12 and drops to 0. But from a diagnostic perspective, it's the same. What I mean by that is if you go to a wall outlet and you probe with black to the ground, and then you probe with red to the shorter one, which is positive, you'll read 120 volts. And that measurement, ground to hot, or ground to power, or neutral to power, or neutral to hot, diagnostically works the exact same way as when you're working on a car. So if you're used to doing open circuit voltage or voltage drops or loaded circuit voltage or anything like that on a car, it's going to act the exact same way, but you have an extra 0. Instead of 12, it's 120. And of course, you can get zapped or shocked if you cross these, which is also true on a car, or if you touch them with your fingers or something like that. Okay, back to the problem on the oven. So what I found is that there is a 100 ohm difference between these two loads, resistors, heating elements. And what that does is with the extra resistance of this long one, which goes to the baking circuit, it consumes more, it consumes more electricity, more amperage. And so the voltage coming in at 115 doesn't just drop to 3 and send 3 to the control valve, it drops to 0.5 and only sends 0.5 to that control valve down there. And what that means is it's missing 2.5 volts. That gas control valve doesn't open, but it's not because of its resistance, it's because of its voltage supply, which is dictated by this guy. And that's because it's a series circuit, unlike a parallel circuit like you would typically find in cars, although there are a couple series circuits in cars. So the nice thing is I did all this without a wiring diagram, and sometimes you have one, sometimes you don't. And I also was able to just swap these out into the two different circuits. The broiler circuit stopped working, the bake circuit started working. So even though I've not ordered a replacement part yet, I already know that it's fixed. And that's one of the diagnostic tips I would have for you. If you're working on something specifically without a wiring diagram, try and find other components that are already installed that are identical or near identical that you can take sample readings off of. I wouldn't have necessarily immediately thought that 350 ohms was terrible, but having another one at 250 ohms confirmed what a better one would look like. Now you can use Ohm's law for a series circuit, and you can calculate how much voltage would be getting to the control valves if you had 250 or 350. So that's also an option to be a little bit more scientific, but oftentimes if you're working on a circuit like this and you're a mechanic or an electrician or a plumber, you're not going to bust out Ohm's law every single day. All right, well, I hope that that was a little bit helpful to you. Perhaps you have this same model and this same problem, or perhaps you're just a guy who has enough electrical skills from Arduino electronics or lawnmowers or cars or something like that, and you want to delve into this and you're intimidated. I hope I showed you a few tips to lower your intimidation, increase your safety, and still let you get to the bottom of your problem. All right, folks, hope that was helpful. If not, give this thing a thumbs down. Have an awesome day, and I hope you had a great holiday.